Good morning. So let us go now to definite integrals. For the properties of definite integrals, if you have here the limits as negative a to a, wherein a are real numbers, then if your f of x is an even power of x, meaning the exponents are even, the constant is understood to be 3x to the 0. Remember that x to the 0 is equal to 1. Any number raised to 0 is 1, right? Okay. So 0 for this purpose will be taken as also an even exponent. Okay? So a constant is considered an even term because that is the same as 3x to the 0. Okay? Now, if your f of x is an even power of x, then when you integrate that, that will be an odd function. What do I mean? If you integrate x to the fourth, this is going to be x to the fifth over 5 plus 2 integral of x squared by power formula, x cubed, you add 1 over the exponent, plus 3 integral of dx, this should be x. This must be evaluated from minus 2 to 2. When you integrate an even function, because you are adding 1 to an even exponent, the result will be an odd exponent. So the result will be an odd function. Okay? We shall be able to prove that this integral or this expression f of a, this is going to be f of a minus f of minus a, right? Okay? Your a is 2. And we will be able to prove that minus of f of minus a for an odd function will be equal to this. Okay? So that's why it will result to 2 times f of a. Let us further do that. So when you substitute the upper limit for x here, this is going to be 2 to the fifth over 5 plus 2 times 2 to the third over 3 plus 3 times 2. Okay? Look here. So, this is minus. Now we substitute the lower limit minus 2 for x. This is going to be minus 2 to the fifth over 5 plus 2 times minus 2 to the third over 3 plus 3 times minus 2. Look at here. Look at this. If you compute this, this is going to be, on your calculator, that would be 266 over 15. While this one is minus of, you compute this, minus 266 over 15. The minus of f of minus a is equal to f of a. So that's why this is the same as 2 times 266 over 15. You get it? So this is going to be 532 over 15. Now, the essence of this property is instead of recomputing this or this substitution, you'll just be able to reduce it to just one substitution. That is of the upper limit. You get it? Now, according to this property, on the other hand, when function of x is odd, this integral with limits minus a to a will be 0. Like this. When we say odd function, the exponents of x are all odd. Okay? So, remember, when we integrate, we add 1 to the exponent, right? So, the odd power will become even. So, if it is an even function, the function of x equals the function of minus x. So, this will be equal, no? The 2. So, what will happen is you subtract equal, the answer is 0. Okay? Look. If we integrate this, this would be 4 integral of x cubed. That is x to the 3 plus 1, 4 over 4. Plus 2, integral of x to the 1 is x to the 1 plus 1, 2 over 2. So, this must be evaluated from minus 2 to 2. So, I can cancel this. So, substituting 2 for x, the upper limit, you have 2 to the 4th plus 2 squared. Minus substituting the lower limit, it would be minus 2 to the 4th plus minus 2 squared. Look at this. This 2 to the 4th is 16 plus 2 squared. So, this is 20. This is f of 2, right? Minus 2 to the 4th, negative to the even is positive. So, this is positive 16, this is positive 4. So, this is 20. This is your f of minus 2. When you are evaluating an even function for certain values of x, let's say a, or 2 and minus 2, the function of positive a equals the function of negative a. So that will give us 0, right? You follow? I repeat. So if your function of x is even, the integrand will be odd, right? And that would be 2 times integral of 0 to a function of x. But if the function of x is odd, okay, it means like this, add exponents. Then, if your limits are the same, except that this is negative, then you may skip the integration. The answer is 0. You follow? Now, the second property of definite integral is this. The integral of f of x dx from a to b plus from b to c of f of x is the same as integral from a to c of the same function. Okay? You just split it from a to b, then b to c. When you notice that you are integrating the same functions, the upper limit of this is the lower limit of this, then you can just make it continuous from a to c. Provided that the function is continuous within a to c, meaning there is no point of discontinuity. There is no point where the function will not be defined. Okay? Example. Suppose we have here a simple example. Let us say integral from 1 to 3 of x squared dx plus integral from 3 to 5 x squared dx. Notice that this and this are the same. So our theory, or this one, says that since this and this are the same, this will be the same as integral from 1 to 5 of x squared dx. Let us prove that. Integral of x squared is x to the 3 over 3. Right? So this is from 1 to 3. Integral of x squared is x cubed over 3 from 3 to 5. So this is equal to integral of x squared is x cubed over 3. Is this the same as function from 1 to 5? Let's see. This is the same as substituting 3 for x. You'll have here 3 cubed over 3 minus substituting 1 for x, 1 cubed over 3. This one plus Substituting 5 for x, so this is 5 cubed over 3 minus substituting the lower limit 3, so 3 cubed over 3. Now notice that this portion 3 cubed over 3 minus 3 cubed over 3, this will cancel out, right? Resulting in 5 cubed over 3 minus 1 cubed over 3. This is the same as evaluating x cubed over 3 from upper limit, lower limit, from 1 to 5. Right? The same as this. You get it? So therefore we say, look here. This is equal to evaluating this. This is substituting the upper limit for x, 5 cubed over 3, minus substituting the lower limit for x, 1 cubed over 3. It is this one. You get it? The function of x integrated from a to b plus integrated from b to c is the same as integral of the function of x from a to c. You get it? Another property is this. The integral of function of x dx from a to b is equal to the negative of integral of f of x from b to a. When you reverse the position of the limits, the upper becomes the lower becomes the upper limit, then the sign of the integral becomes negative. Okay? Alright. So, for example, we integrate x to the 7 from 1 to 2 dx. So, our theory is that the integral from 2 to 1 of x to the 7 dx will be the negative of this. The sign will be reversed when you reverse the position of the limits. So the integral of x to the 7 is x to the 8 over 8 with limits from 1 to 2. What we want to prove is that this is negative of integral from 2 to 1. Okay? So this is the same as x integral of x to the 7, x to the 8 over 8, but this is 2 to 1. Are they really equal? This is equal to the negative of this. So, if you substitute 2 for x, 2 to the 8 over 8, substitute the lower limit for x, this is 1 to the 8 over 8. This is negative of substituting 1 for x, you have 1 to the 8 over 2 minus substituting 2 for x, 2 to the 8 over 2. Negative, negative, positive. So you'll get 2 to the 8 over 2. Negative of 1 over 2 is negative. So they are indeed equal. You get it? This is for any function of x, odd or even. You get it? Any algebraic, meaning x to a certain power, this is going to be true. You follow? Let us have here more example. So the integral from 1 to 4 of this expression. Remember that square root of x is the same as x to the 1/2, right? Okay? This is the same as x to the 1/2. Now, cube root of x is the same as x to the 1/3. And this is 1 over x to the 1/2. So this is the same as 1 over x to the 1/2, right? But by property of exponent, this can be written as x to the minus 1/2. So the mathematical shortcut is when you bring up a numerator, you reverse the sign of the exponent. If you bring down a numerator, you reverse the sign of the exponent. You get it? Okay. So therefore, this is now the same as integral from 1 to 4 of 3 square root of x is x to the 1/2 plus 1x to the 1/3 plus x to the minus 1/2 dx. Now, by power formula, we say, isn't it, that the integral of u to the n du is what? U to the n plus 1 over n plus 1. We keep on repeating this one because this is really a very important formula in integration. You have to memorize that by heart. So this is going to be equal to 3 integral of x to the 1/2 is x to the 1/2 plus 1, that is 3/2. What was our shortcut here? 1 plus 2, 3 over 2. That's it. So that is when you add 1 to a fraction, you just add the numerator and denominator over the denominator. So x to the 3/2 over 3/2. So pwede nating iakyat yun to dito. We can bring up to here. So 3 times 2. Okay? Now, plus integral of x to the 1/3 is x to the 1/3. 1/3 plus 1. This is 4/3. 1 plus 3, 4 over 3. Over 4/3. Okay? Plus integral of x to the minus 1/2 plus 1 is x to the minus 1/2 plus 1. Minus 1/2 plus 1? 1/2. Or that is minus 1 plus 2, 1 over 2. Okay? So minus 1/2 plus 1 is 1/2 over 1/2. Okay? So this is from 1 to 4. Okay? Let me repeat again. Why I write the denominator to the numerator? It is because of this. So, when you divide a certain number by a fraction, let us say a over b. Okay? N divided by a over b is the same as n times. You reverse this, b over a. Right? So, that's why I write the b on top. So that is a mathematical shortcut for the simplification of this to this. You get it? Okay. So that's why x to the 3/2 over 3/2 is the same as x to the 3/2 over 3 times 2. Okay? Okay. So evaluating it from limits 1 to 4, this is going to be equal to, substituting the upper limit for x, this cancels out. So this is going to be 4 to the 3/2 times 2 plus 3/4, 4 to the 4/3 plus 2 times 4 to the 1/2 minus, substituting the lower limit, you have 1, 1, 1. 1 raised to n exponent is 1. No? So this is going to be 2 times 1 to the 3/2 plus 3/4, 1 to the 4/3 plus 2 times 1 to the 1/2. So calculating this, you'll have here 24.762, that is this one, minus this one, which is 4.75. So computing this, you'll get here 20.012. This is going to be your integral. Okay? So there are many ways to solve this expression. One way is using the calc function. So if you will use the calc function instead of entering this entire thing in your calculator, which is doing the job twice, we can reduce this to 50% effort. How? Input this expression in your calculator. So you have here 2 alpha x to the 3 halves. So x in your calculator is alpha close parenthesis. Okay? So you press these two keys, alpha, then close parenthesis. That is x. To make the exponent, you press the key x to the rectangle. So your calculator will be on top. So this is 3 divided by 2. Now, don't forget, after you press 3 divided by 2, you press the right arrow key to bring it down again to the level of x. Okay? So, plus 3/4 plus 3. To write 3/4, so 3, press the fraction key, then 4. After you press this 3, it is just like divide, but in fraction form. So 3 divide by 4. So you'll have this form, 3/4. But be sure to press again the right arrow key. The right arrow key, then alpha x, that is alpha close parenthesis, that is x, raised to 4/3. So you press this again, then 4 divided by 3. So you press the right arrow key again to bring it down again. So plus 2 x to the 1/2. So that is alpha x to the, press this again, 1/2. 1 divided by 2. You can press divide or you can press this key. You get it? Only the presentation in your calculator will differ, but the operation will be the same. After you enter the entire thing, you press the calc key. Once you press the calc key, your calculator will display what is your x. Okay? This is the calculator display. What is your x? You input your trial value. The x that we want to substitute is 4. So press 4 equals. Your calculator will display 24.762. That is this one. Then press equals again. Your calculator will ask you again, what is your x? Notice that below this, there is the last x that you entered, right? That is 4, right? So, you want now to input not 4, but 1. So, press 1 this time, 1 equals. Once you press 1 equals, your calculator displays the value of this time with x equals 1. So, and the answer will be 4.75. Then you just compute 24.762 minus 4.75, you'll get this one. You get it? Another way to do this, if you intend to use multiple differentiation or multiple substitution, is this. Use the mode table. Mode table. So mode table is mode 6. Okay? And then your calculator will ask you, what is your f of x? You just input this one. Okay? You just input this f of x. So press 2 alpha x to the 3 halves plus 3/4 x to the 4/3 plus 2 alpha x to the 1/2. Then press equals. Your calculator again will ask you, what is your start? The start means your first value of x. since we just want 2x's 1 and 4, so your start value will be 1 equals. Then your calculator will again ask you the end, meaning the last value of x. Then you input 4 equals. Then your calculator will ask you step. Since we are not interested with a value between 1 and 4, you just press step 3. So that 1 plus 3, 4. Step, you press 3 equals. Then your calculator will display, this is the x, this is the function of x. X is 1, x is 4. Okay? So, you'll get here in your calculator 24. 1, it's 4.75. For 4, it's 24.762. You'll get these two values right away. You get it? But the simplest, of course, if you're allowed to use calculators with integration like the Canon F789 SGA, then it would be better. Okay? But if you are allowed to use Casio FX991ES, that would be faster than Canon. Okay? So, faster, and I think it's cheaper. Okay? In our review center, we still have a stock of Casio FX570ES. Okay? So, you might be interested to buy it or order, then we have stocks available. Okay? Likewise, we have a stock available for Canon, whichever you prefer. Okay? Alright. So, if you are allowed to use calculator in Canon F789 SGA model, this is how you do it. You can do the definite integration using your calculator. Just press integral symbol, then input the function 3 square root of x plus cube root of x. The cube root of x is shift square root. Shift the square root key. Okay? The shift square root key is actually cube root of whatever function you will enter. Okay? So then, shift cube root or square root of alpha x. Alpha, close parenthesis, this is our x. No? So then, you press the right arrow key. So you have to press the right arrow key here. Okay? Then, this is 1 divided by square root of x. So 1 divided by the square root of alpha x. Okay? I will just write it in the way you see it there. So, square root, then alpha, close parenthesis, it's this one. Okay? Then, you press the right arrow key twice. The first one to bring it out of the square root. Then, another arrow key to bring your cursor to this. Okay? So, once you press the second arrow key, right arrow key, your cursor will shift to this point. So, you input the lower limit, 1, then press the up arrow key or right arrow key is okay. Your cursor will move to this. Input the upper limit, 4, then equals. Your calculator will process the value, then it will display the result. The result will be 20.012. It will be the same as this. You get it? In Casio FX991ES, the process is the same. So they are identical. There's no difference. Okay? Here we are asked to evaluate this integral manually. So since the numerator is of higher degree than the denominator, this is third degree, this is first degree, the technique is to divide. So we divide x cubed plus 27, divide this by x plus 3. remember, in division of polynomials, the divisor is just the one containing x or the highest power of x, but the multiplier will be the entire thing. So we start with x cubed. X cubed over x is x squared. X cubed divided by x is x squared, right? So 3 minus 1, 2. Okay? Or you cancel 1x, what will remain is x squared. So x squared times x is x cubed. X squared times 3 is 3x squared. So we subtract. X cubed minus x cubed, the x cubed will cancel. So minus of 3x squared. Minus 3x squared over x is minus 3x. I repeat. Minus 3x squared over x. 1x will cancel. So this is minus 3x. That one. Then minus 3x times x minus 3x squared minus 3x times 3 minus 9x. So we subtract again. This minus this will cancel. So minus of plus 9x. 9x over x is 9, right? I repeat, 9x over x, this is 9. So 9 times x is 9x. 9 times 3 is 27. Let me put it underneath the 27. We haven't used that 27 yet. 9 times 3 is 27. So we now subtract. 27 minus 27, this will cancel out. 9x minus 9x cancelled. So we are left with 0. So this divided by this is exact. So therefore, our integral will be the same as integral from 2 to 3 of the answer x squared minus 3x plus 9. So this divided by this is the same as this one. So this is dx. So integrating this manually using merely power formula, integral of x squared, x cubed over 3. You just add 1 to the exponent. Minus 3, this is the same as x to the 1. So this is going to be x to the 2 over 2. Plus 9, integral of dx, that is x. This is evaluated from 2 to 3. So, substituting 3 for x, then substituting 2 for x, you may use any technique using calc or mode table, no? So, if you use calc, you have here, be sure you're in mode 1, so you have alpha x cube. Cube is shift x squared, no? So, this is alpha x cube. Cube, I repeat, is shift x squared. So, you have here, input this in your calculator, then press calc. Then input 3. So, you'll have 3 cube over 3 minus 3 over 2, 3 squared plus 9 times 3. Then, you subtract, substituting 2, you have 2 cube over 3 minus 3 halves times 2 squared plus 9 times 2. Okay? So, you calculate this. This will be, or I repeat, pwedeng calc. Just input this function in your calculator, then press calc. Your calculator will ask you what is your x, input 3. Your calculator will automatically replace all x's or 3 for all x's. Your calculator will give you, what is that? This is 22.5 minus, I press equals again, then replace x by 2. So this is 14.6 67. You compute this is going to be equal to 7.83. Okay? So this is going to be this integral. You follow? Let me show again for those who are not yet knowledgeable in your calculator. How did I do this? Method 1. Using calc. So I input the function in our calculator. So you have, let me do this step by step. So alpha x, I repeat, x, I will just make here the shortcut. If you want x in your calculator, this is the same as, the key for this is alpha, the alpha key, then close parenthesis. Okay? And then for squared, there is a key for that. So you have here, if you want to square something, the key there is x squared key. Okay? Now for cube, if you want to cube something, the key there is shift x squared. Shift x squared is for cube. Okay? You follow? For square root, if you want the square root, then you just press the square root key. If you want the cube root, then you just press the cube root key. Okay? The cube root key is shift square root. Okay? So these are functions which will help us. Okay? And yung divide could be the division symbol, divide. It could be the division symbol or the fraction symbol. Okay, this one. You get it? If you use the fraction symbol, it will appear like this. If you use the division symbol, it is 3 divided by 2 symbol. You get it? Okay. Well, using the calc, input this in your calculator. You press x cube. How do you press x cube? Alpha x or alpha close parenthesis, then shift x squared. That would be this one. Okay? So you press x cube, then press fraction, that would be divide. For this one, what is the key? This would be alpha close parenthesis, that is for x, then for cube, shift x squared. So this would be x cube. Then divide, your cursor will go here by 3. Be sure to press right arrow key so that your calculator will return here. So minus 3 halves, it's 3 fraction 2. Press the right arrow key so that your cursor will move here. Alpha x squared. So x squared. What is alpha x? Alpha x is alpha close parenthesis, then squared key. Okay? So I repeat, this one is alpha x, alpha close parenthesis, then x squared key. So you'll have this. So when you press the x squared key, no need for right arrow key. No? Okay? Then plus 9 alpha close parenthesis, that is x. Okay? So then press calc. You will see this in your calculator. Then press calc. The calc key. Once you press the calc key, your calculator will ask you, this one represents display, huh? So your calculator will ask you, what is your x? Calculator is asking you, what x do you want to substitute? You substitute the upper limit 3, press equals. Then your calculator will display the value of the function of x with x equals 3. And you'll get here 22.5. It actually will display 45 over 2. You want the decimal notation, so just press the fraction to decimal key. It is reversible. Okay? So fraction to decimal key, it's just second column from the right. Okay? So above the delete. So fraction to decimal, your calculator will convert this to decimal. That is 22.5. You get it? You follow? Then just press equals again. Once you press equals, your calculator will return you to this stage. Your calculator will ask you again, what is your x? You just input the second value, the lower limit, that is 2. Then press equals. Your calculator will display 14.666666. The last is 7. Okay? So, do you follow? This is the function of x with x equals 2. You get it? Then you just subtract this minus this. You get it? So, the other method, method 2, is using mode table. Okay? Using mode table. Table in Canon is 6. Mode 6. This is mode 6. That is the mode table. Once you press mode table, your calculator will ask you what is your function of x. You just input this function, this one. This is the one that we are evaluating. So, you have x cubed over 3. The process of entering the function is the same as this. So, x cubed over 3 minus 3 halves of x squared plus 9x. Okay? Then, press equals to signify the end of the function. Your calculator will ask you start. This is the first value that you want to enter. We begin with the lower limit, that is 2. So, press 2 equals. Then your calculator will ask you what is your end value or last value you want to substitute. You input 3. Okay? Then press equals. Then your calculator will ask you step. Step is the difference between 2 and 3. So that is, we don't want any intermediate value. So we just press 1 equals. So that 2 plus 1 is 3. Okay? So press 1 equals. Your calculator will display this one. This is the display of your calculator. This is the x. This is the f of x. For x equals 2, you'll get here 14.667. For x equals 3, you'll get here 22.5. So you have f of x at x is 3, f of x at x is 2. This minus this, you'll get 7.83. Do you follow? Now, the simplest, of course, is using our calculator, no? So, in this problem number 22, we are integrating the same thing but using our calculator. So, to do this, in your calculator, press the integral key. Then, you press x cubed plus 27. So, this will be alpha x, no? So, alpha, close parenthesis. This is the key for x. May be done in two ways. It may be the exponentiation or the direct cube key. So, let me use the direct cube key, the shift x squared. So, this will be the power of 3. Okay? This one. Okay? Now, the beauty of using the direct cube key is you don't need the right arrow key. So, this will represent x cubed now. Then, plus 27. Okay? So, we are done here. So, if you press the fraction key, what will happen is this one. you'll get x cubed plus 27 over. This will not be included in the over. You get it? If you want to write it really this way, so you must input an open parenthesis here. Okay? Then, before pressing here, press the close parenthesis here, so that the entire thing will be considered as 1. Then, press the fraction key. So, what will appear is x cubed plus 27. There is an open close parenthesis over. Okay? So, by this time, the display in your calculator, I will show the display. It would be x cubed plus 27 over this one. Okay? Your cursor is currently here. So you divide it by x plus 3. No need for open close parenthesis because you don't have any intention to divide it again. So then over alpha x, okay? So alpha close parenthesis, again, this is the key for x. Then plus 3. We are writing here. Okay? Under. So in order to bring it up here, so press right arrow key. The right arrow key is at the center of your calculator, there are 4 keys like this. In Canon, these are 4 different keys. Okay? But in Casio, this is in the form of a circular navigator. Okay? It's just one key. You just press on the part you want to use. Okay? Press the right arrow key. Your calculator's display so far will be something like this. X cubed plus 27 over x plus 3. By the way, there is an integral symbol here. Okay? Integral symbol with upper lower limits which are still blank. Okay? Alright. Now, we are now ready to put the limits. You press the right arrow key, your cursor will shift to the lower limit. Okay? So, input the lower limit which is 2, then press again the right arrow key. Your calculator will move to the upper limit. What is the upper limit? 3, then press equals. Then your calculator will process this. Okay? So, processing this, your calculator eventually will show the result. And it is, you'll have 47 over 6. To find it in decimal, press the fraction to decimal key. And you'll have 7.83333. Okay? So the display will be 7.8333333 or 7.83. Okay? Same result as we have a while ago. Do you understand? Let's have this one. We are to evaluate this using our calculator. So, this is going to be in our calculator. You press the integral symbol. So, once you press that, there will be a slot or a space for the lower and upper limit. Then, you press the square root key. So, your cursor will be here. So, anything that we input will be inside the square root. So, you have 4, press the minus, then 2, x is alpha, close parenthesis. Okay? So, by this time, what is displayed in your calculator is integral lower limit, upper limit blank. So, square root of 4 minus 2x. This is so far the display in your calculator. Okay? So, be accustomed to my symbol of calculator display. This, when I use the diamond, this is what you are seeing in your calculator. Huh? Okay? Then, you have here, press now, right arrow key. The purpose of the right arrow key is to go out of the square root. There is a dx here. Okay? So, to go out of the square root. Then, press right arrow key and you will be, your cursor will shift to this one, the lower limit. Input the lower limit, 2. Then, to move up to the upper limit, just press right arrow key again or upward arrow key will be okay. So, once you press this, your calculator will shift you to the upper limit space. So, press 4, then press equals. Your calculator will now process it and will display the value equal to. Notice that the message of your calculator is math error. What is the source of math error? The source of math error is this. When you substitute 4 for x, whenever x is greater than 2, this becomes negative, right? Correct? So this becomes negative. And the square root of a negative number is an imaginary number. So the integral is imaginary. Okay? You follow? And it is beyond the scope of our lecture to evaluate the integral of an imaginary number. Do you follow? What about if the limits are 0 and 2? So we input the same process except that this is 0 and that this is 2. You press it. So you bring the cursor to lower limit here, 0, then this would be 2 equals. So you will get here 2.66666667. So the display in your calculator is 0 to 2, integral of 4 minus 2x dx is equal to this. You follow? You get it? What about this one? As you can see here, the variable is y. But look at your calculator for the integral. When you press the integral symbol, it's dx. So what you will do is that the y will be entered as x. You follow? When using the integration function of your calculator, all variables must be entered always as x. Okay? So therefore, this must be entered as, press the integral symbol. Then, to input 1 over y squared plus 4, so you just press 1, then fraction. So, your calculator display so far will be like this. It would be 1 over, this is cursor, then dx. Okay? So, we are now entering, after you input this, we are now here. Okay? So, input the denominator, which is y squared plus 4. Let me repeat, y must be entered for this purpose as x. So, alpha, close parenthesis, this is x squared. So, press the squared key, x squared, then plus 4. By this time, your calculator displays this one. Integral, blank lower limit, blank upper limit, then 1 over x squared plus 4 dx. But your cursor is still here. Then press the right arrow key, the first right arrow key, to bring it outside the denominator, to bring it here. Then press again the right arrow key in order to bring it to the lower limit space. Then press the 2, the lower limit, bring it up by pressing either the right arrow key or up arrow key. Okay? So, press this and that brings you to to this. The upper limit, 4 equals. Your calculator will display and it will say processing. Okay? So, wait for the answer. And this would be 0. So, the display will be 0.16087527772. So, this is the display in your calculator. Okay? You get it? Meaning the integral of this is equal to this one. You follow? So what about this one? The integral from 0 to 1 of this expression. So again, this is dt, but in our calculator, we will input t as x. So this will be entered as square root of 3x minus x squared. So to do this in your calculator, again, press the integral symbol, then the square root. Your cursor is here, meaning anything that you will enter next will be inside the square root. So this will be press 3, then alpha x, or that is alpha, close parenthesis, this is our, let me repeat, x minus t squared, that is alpha, close parenthesis, this is the x, then squared, press the x squared key. This is the key for x squared, right? Okay? So, alpha, close parenthesis, x squared, that is x squared. Then, press the right arrow key to go out of the square root. Then, press again the right arrow key to bring your cursor to the lower limit. Okay? So, the lower limit is 0. Then, press the right arrow key in order to bring the cursor to the upper limit, which is 1, then press equals. Your calculator will process it for a while, and then eventually it will give you the integral of 0 to 1 square root of 3x minus x squared dx is equal to 1.031275954. So this is the value of the integral. You follow? Now when integrating using your calculator and the function or the integrand involves trigonometric function sine, cosine, tangent, cosecant, cotangent, secant, you will have to express your calculator in radian mode, no? So I repeat, use radian mode. To convert your calculator to radian mode, just press shift mode, shift key, mode key. Your calculator will display a menu. And the number 4 is for radian mode. So press number 4. This is the display. So press 4. Okay? So your calculator, you'll notice above a very small letter R. Okay? So you are now in radian mode. So this is integral of sine squared theta d theta. Theta must be entered as x. All variables must be entered as x in integration. So therefore, you press the integral key. So then, you cannot input sine squared in your calculator. It must be sine of theta squared. But I repeat, theta must be entered as x. So, open parenthesis to bring sine inside the parenthesis. Then, press the sine key. The sine key comes with a built-in open parenthesis. Okay? So, I repeat, you don't need to put open parenthesis. It is built-in your calculator, right? Okay? So, when you press the sign, it is with open parenthesis. Then press theta, which will be entered as alpha close parenthesis. Okay? Alpha close parenthesis. This key, I repeat, is for your x. Then close the built-in open parenthesis of sine. Then close this open parenthesis that you entered, then squared. So this time, your calculator displays integral from blank to blank of sine alpha x, close parenthesis. You square that. So press the squared key, right? So there is a dx here. So press the squared key. So your calculator displays this one. Okay? Integral. Then press the right arrow key to bring you to the lower limit. So input 0. Then press the right arrow key to bring you to the upper limit. So therefore, press pi. Pi is shift exponent. Notice that on top of the exp, exponent key, there is the red pi. So to activate this number on top of a key, shift is the key. So shift that key, meaning you are activating this red number or red expression. So shift exponent is the pi. So divided by, or you may use the fraction key, divided by 2. By this time, your calculator displays this one. Integral from 0 to pi divided by 2 sine alpha x squared dx. So press equals and your calculator will display the value. And you'll get 1/4 of pi. If you want the decimal value, press fraction to decimal and you'll get 0.785. You get it? Okay. So what about this one? So this is going to be integral key, then open parenthesis, then cosine, it comes with a built-in key, it's just one key, then alpha x, alpha, close parenthesis. Notice that on top of the close parenthesis is the blue x. So that's why to activate the blue on top of a key, press alpha. Alpha, close parenthesis is not close parenthesis but the blue letter, that is x. Okay? So alpha x, close parenthesis, this close parenthesis is for this one. Okay? Then close parenthesis again in order to close this open parenthesis. So by this time, you'll have cosine of alpha x. So you cube it. Cube is shift x squared key. Okay? This is for the cube. Then, you press right arrow key for the lower limit, 0. Right arrow key for the upper limit. Then pi. Pi is shift exponent. So this is the key for pi. Then divide by 2. That is pi over 2. Okay? So this is the key for pi. Then divide by 2 or pi over 2. Okay? Then press equals. Okay? Equals. So your calculator will display 2/3. So this is going to be the integral. What about this one? How do you input cosecant and cotangent? Cosecant is 1 over sine squared theta. Cotangent is 1 over tangent of theta. You get it? Okay. So let us do this in our calculator. Integral key, open parenthesis for the cosecant squared. So that is 1 over, okay, over, this will be entered as fraction. Okay, so over sine squared, so that would be open parenthesis, then sine it comes with a built-in open parenthesis, then alpha x. Okay? So, this would be alpha close parenthesis. This is for x. Then close the open parenthesis, then close the open parenthesis again. So you have to put squared. So this is x squared. So we are done with 1 over sine squared, right? So press the right arrow key, close this parenthesis. Then open parenthesis for the tangent. No need for open parenthesis. You just press 1 fraction so that it is 1 over tangent. Then the tangent key, it comes with an open parenthesis, then alpha x or alpha close parenthesis for x, this one, then close this open parenthesis. Okay, so we are now 1 over tangent of x. Okay, press the right arrow key in order to bring it outside the denominator. Okay, so last is the limits. So press the right arrow key. So you are now beside the d theta. Press the right arrow key again. It brings you to the lower limit. Pi over 4, so that is shift exponent. So this is the key for pi divided by 4. So we are done with the lower limit. Bring it to the upper limit. Press the right arrow key, then pi again, shift exponent. So this is the key for pi, divide by 3. So divide by 3. Press equals. Your calculator displays the answer. So you'll get this as 1/3. You get it? Just be sure that you are in radian mode. Okay? So what about this one? So this one, press the integral symbol, sine cube theta. Input this. How do we input that? So that is open parenthesis sine. Sine key is with a free open parenthesis. Then alpha close parenthesis. This is for x. Then you close this open parenthesis. This one. This one closes this open parenthesis. Okay? So then for this parenthesis, for this open parenthesis that we press, close it again by a close parenthesis. Then cube. Cube is shift x squared. Or an alternative to this is x to certain exponent. Your cursor will move to this, then 3, then press right arrow key. So this would be an alternative for x cubed. So this one is 2 strokes, this is 3 strokes. Okay? So by this time, you just on your calculator, what is displayed is integral blank to blank of open parenthesis sine alpha x quantity cube dx. Your cursor is here. Okay? You follow? So we now input cosine 2 theta. So again, open parenthesis. Okay? I'll color it with blue. Open parenthesis, then press it. Cosine comes with a free open parenthesis 2 theta. So press 2, then alpha x. Alpha close parenthesis. This is the x. Okay? So close the parenthesis, this one, the free open parenthesis, then close the open parenthesis that you entered. So we have cosine 2x. So you raise it to the 4th. So this time you press the x exponent key, then press the 4. Once you press this, you are in the exponent. So this is to the 4th. So we were able to raise cosine 2 theta to the 4th. Then bring it, press the right arrow key to bring it down again so that we are ready for this one. So press open parenthesis, then press the tangent key. The tangent key comes with a free open parenthesis. Then you have here 3 theta. So 3 alpha x, which is close parenthesis. Okay? So then close this one. Then close parenthesis for this one. So we already have tangent 3x. Then cube it. The cube is shift x squared. This is the cube. Then, so we already have tangent 3 theta cube. Then, to bring it to the lower limit, press the right arrow key, press 0, then bring it to the upper limit, press the right arrow key, pi over 2. So, shift exponent, this is the pi. Shift key, exponent key. Then, divide by 2 equals. So, press equals, your calculator will display the result. And it is, so as you can see, your calculator will display math error. Your calculator will display math error if there are divisions by 0 or inconsistency or infinity or undefined. Remember that the tangent of 3 times pi over 2, that is 3 pi over 2 is 270. The tangent of 270 is infinity. Negative infinity to be more specific. So your calculator cannot handle that. Okay? So as we cannot integrate that. Okay? So let us have another problem. Number 31. If this is number 31, this is pi over 4. Only pi over 4. Meaning 45 degrees. Pi is 180 divided by 4. That is 45 degrees. So the limits, everything will be the same except that this is pi divided by 4. Okay? So just press the right arrow key to return to the original. Then bring your cursor to pi over 2. Delete the 2. Replace it by 4. Okay? So equals, it will process. So what did you get in this particular problem? So as you notice, you waited for long. Our calculator processing, or if you are using a Casio, it is a blank screen. Then eventually, after a long wait, perhaps more than 15 minutes, it will display a math error message. So same thing as when the limit is pi over 2. Now, come to think of this, I am giving you time. You just pause the video in order to think of the reason why your calculator cannot compute this while our limit is already 0 to pi over 4. It's only 45 degrees. Now, I want you to answer that after the next problem. What if, let me make this number 32. What if this is pi over 9? So the only thing that will be changed in our step here is this one. Pi over 9. You try to compute that again in your calculator. Changing the 9, the limit from pi over 4 to pi over 9. And you compute that. And you will get there something like, I already rounded this off, 3.1 times 10 to the minus 3. You get it? So it won't take 2 seconds or 3 seconds for your calculator to compute it, right? So now, let me ask you again, why is it that your calculator cannot compute 0 to pi over 4. Now, definitely, there is no indefinite or there is no undefined value for sine and cosine. Sine and cosine are defined for all values of theta, right? Our problem really is in tangent. In tangent, there is an undefined value for tangent. We know that in our axis, this is 0, this is 90, this is 270 degrees, this is 180. In radians, this is pi, this is pi over 2, this is 3 pi over 2. Now, the tangent of 90 and the tangent of 270 are undefined. Okay? So, tangent is undefined in this region. Okay? Or the slope is really vertical, right? So, in here, when this is pi over 4, remember the angle is not theta. It's 3 theta. So, 3 times pi over 4 is 3/4 of pi or 0.75 of pi. Pi over 2 or 90 is just 0.5 of pi. Right? So it means from 0 to 0.75 of pi, it passed through the 90 degrees angle or the pi over 2. So, in our computation of the integral from 0 to 0.75 of pi, somewhere in between, you will pass through the 90 degrees angle. And because of that, because of the value here, of the error or undefined value of tangent 3 theta in this angle, if this is pi over 4, this won't give a value because the tangent of 90 between 0 to 3 times pi over 2 is undefined. You get it? So you cannot have a limit wherein it will make the tangent of an angle the tangent of 90 degrees or tangent of pi over 2. You get it? Because tangent of pi over 2 is undefined. Okay? You follow? You get it? Math error in your calculator is a result of undefined value somewhere in between. You get it?